Okay. Hello everybody. I'm Oscar Matilla from Synchrotron, and I will be the chair of the last session of today, which is from Carla Gelpí will come to talk about Sagrada Família. And we scheduled this keynote speaker. You know that normally keynote speakers are scheduled at the starting time of the day. In this case, we did an exception because just to link it with a big portion of you will have the opportunity to visit Sagrada Família this afternoon. So I will introduce Carla Gelpí. Carla Gelpí is a professor of structural calculations at Polytechnic University of Catalonia. Also, he has given other classes in other universities, but he's not here to talk about his academic trajectory, but to talk about his work in the architecture office of 2BMFG. He's the head of project there, and this architecture office has been working in the Sagrada Família for the last 34 years. I think all of you know about Sagrada Família. It's an iconic view of Barcelona and worldwide. And you know that this project started in the 19th century by Antoni Gaudí. And according to what he was telling me, Antoni Gaudí at the starting point realized that at that time, first due to the magnitude of the project, he will not see how it finished, but also because technologically it was not feasible at that time. So I can see somehow some similarities with our large project that are being presented. No, the first one is the time we take to finish our project. No, sometimes it's similar, but also the fact that the technology has to be evolved at the same time as a project starts. Even there is no technology at the time for finishing, and then there come people as us to try to find technological solution. So I think that today, Carlos will give us a different perspective of Sagrada Família, much probably. Thank you very much.
Puc tenir llum aquí, una mica? Can I have a little bit light? No? Well, good morning, everyone. Thanks for coming, and thanks to the organization to give us the possibility to explain our passion. I would like to expose you this story, the story of one of the most incredible building that's under construction actually. Is the Sagrada Família, as you can see. His history began in 1882, and most of you maybe knows, but the original project was commanded to Francesc de Paula Villar. He was an architect, a diocesan architect, and the Association of Devots de Sant Josep, this is a religious association, commanded to him the construction of this building that must be expiatory temple. Expiatory temple means that the money, the capital they need to construct provides from anonymous donators. Then in 1882, the first stone was put on place, and they began a project that you can see. That's a neo-Gothic cathedral. In 1883, In 1883, because some disagreements between the clients and Francesc de Paula Villar, the architect, Villar resigned the works, and the association commissioned to Gaudí to continue the works following the project of Villar. He has 30 years old. But who was Antoni Gaudí? Antoni Gaudí was born at 1852 in Reus, near Barcelona, and at 1878 graduated in high school of architecture. From this point, he participated in the Universal Exposition. He made lots of buildings near Barcelona and also out of Barcelona, and he collaborates habitually with Francesc de Paula Villar from 1977. Then, with these works during 20 years, Crypta Güell, Parc Güell. Güell was a Catalan industrialist, politician, and patron, and he had a special interest in modernism architecture. Then Gaudí was a very rare architect, and he made a lot of buildings that were extraordinary and very special. And these are the images we have in the head when we talk habitually about the Gaudí works. Normally, we see buildings with geometry, complex geometry, but also with some kind of, I can say, chaotic or aleatory forms. These are, I think, these are parabolic arcs, or this facade in Milà House. That's La Pedrera. La Pedrera is the quarry, is the Catalan name for the quarry. Then the image for the people was that was a quarry. Then Gaudí, at his time, was not an architect without polemics. He followed two works until 1902. At 1902, he dared that he could present a different proposal to the Sagrada Família, a different proposal than the project that he has 20 years following about the project of Villar. And he presented that sketch. And the clients accept. And he was then 50 years old, and he had already enough prestige, national and international. Then the clients accept the change from neo-Gothic to modernism. Following a bit the life of Gaudí, then we return to Sagrada Família. At 1914, when he followed and finished all the works he had in Parc Güell and Colònia Güell, when he finished these works, he devoted himself entirely to the project of Sagrada Família. To the point that in 1925, he began residing inside to the workshop of Sagrada Família. But not during a lot of time, because at June of 1926, 3 days after being beat by a tramway, he died in Barcelona. We return to the temple. This one was the first sketch he presented to the patrons of the Associació de Devots de Sant Josep, and these were the developments he began when they approved, and he made a proposal that looked like outside, looked like a mountain with a very easy similar reference in the mountain of Montserrat. This is a chain of a massif near Barcelona. And he made, or he projected a very tall building, the Jesus Tower. Jesus Tower is 172.5 meters over the street. Only because man's work can never surpass the work of God. Montjuïc is another mountain in Barcelona, has 175 meters. This was the external view, but inside he decided to make a forest with the light entering between the leaves of the trees. He tried to make a forest. These are sketches, reproduction of the sketches of Gaudí from the first proposals with a bit classical section of 5 naves building, or 5 naves church, changing to more complex solutions for the pillars and not symmetric solutions for the arcs in the square and the roof, and the definitive section that solves the pillars of the main nave and the secondary nave like a trees. These are the plaster models he used to make the project. Normally he worked with plaster models at big scale. In this case is 1/25 scale. And this is the definitive solution work by his workshop. This is a superposition between the project of Villar in blue and the red one from Gaudí. The difference is very clear. The walls disappear almost. They convert a succession of points in plan. That means light must cross all the facades, all the roofs. This is a sentence from Gaudí. He defines himself as a geometrician. He considered that the form emerged from a structure and the structure emerged from the loads. That's, for us, very simple to understand, but when the Neo-Gothic or Modernism were composing facades and buildings and then exiging the support of the loads, the vision of Gaudí was absolutely organic, absolutely geometric. He believed the loads must trace the form of the building. These are the upper roofs on the main nave and the sacristy with his forms. And he was an intuitive scientist. He modified the forms with the weight. When he used these small weights to simulate the real weight of the building, he could change the directions and the form of the arcs and the plates, moving or increasing or reducing the weight he put in every one of these points. Then he searched to solve mechanically or statically the geometry he was looking for. This is his sentence about I calculate everything first by assuming certain weights to find the funicular. The funicular is the geometry that he obtains and the direction he obtains on the cable structure. Sorry, these are cables that are covered with ropes, but the cables were the direction of the arcs, the geometry of the arcs. And he said, I can vary the funiculars, and in this manner the logical form emerged from the needs. Gaudí also Gaudí also was a planner. And he had very clear the vision of his building must be from the four corners to be always to face two facades of the building. Then he made this project in 1912, approved by the city. At this moment, it was not a city, the Sant Martí dels Provençals, and this was the initial planning around the Sagrada Família. This was more or less the state of the works at 1920, more or less. Was a bit before that that Gaudí changed absolutely his habitual form of work. And this is the point where I want to make a little parenthesis to explain that this building, is not free of controversy. Many people say it's anachronic to build a cathedral at the 21st century, or this is not the building that Gaudí could construct, because only Gaudí could construct the Sagrada Família. But more than 4 million people every year visit Sagrada Família, and it's not because our team. It's because the geniality of Antoni Gaudí. Because the actual team, we are more than 100 people involved in the project and the construction. We are following the project of Gaudí. And the question is, how is it possible to follow the project of Gaudí? Well, it's possible, and that's a liaison with the point where I stopped before, because Gaudí changed the normal way to project, and he began to work intensively to let how much more possible plaster models, writings and drawings, but overall he searched the way to let the laws to follow the temple. These are drawings. This is the workshop for plaster models. You can see pieces, serial pieces that repeat can make the general and genial forms. These are another plaster model in the glory facade. And this is the model, this is actual, okay, with made following all the laws we find in the writings, drawings, and plasters. As he said to his chronicle, César Martinell, great temples were not the work of just an architect. I know that the personal taste and techniques of the architects succeeding me will have an influence on the work, but I don't mind. I think it will be to the benefit of the temple. A work like this should be the offspring of a long era. The longer, the better. From 1914, he only worked in Sagrada Família. And he based his design in these plaster models and in laws, in geometrical laws based in ruled surface. In ruled surface surfaces geometry. From these models he made, he extracted the drawings in 2 dimensions, mainly from photographs. The main geometric rule surface he used were the hyperbolic paraboloids, revolution paraboloids, and revolution hyperboloids for all the surfaces, and used the catenary arcs to define the axis of pillars. At the same time, he used traditional materials like stone, mortar, iron, and ceramics, but he conceived the vaults of the central nave and the pillars will have to do, but he didn't know how, but they had to do with reinforced concrete. He began a bit using it at one of the Nativity towers. And he knew that the technical limitations he had, as such tall building, could be solved in the future with the progress of the technology. Then he was a geometrician, intuitivist, and mathematics, because he conceived a relation between all the geometric elements. In this case, we have the table of the pillars, all the pillars of the Basílica. And, for example, because it will develop, the beginning of all is this measure, and this other measure. The main nave have his model of 7.5 by 7.5 meters is the distance between the pillars of lateral nave. And he used the multiple or the part in relation not to 10, not in base 10, but in base 12, like the apostles. Gaudí was very, very religious, and the Sagrada Família is an authentic lesson of symbology, religion symbology. Then applying this, for example, in the column of 8, C8 column, this is these columns on main nave and these other in the side naves and also in the apse, we can, looking at here, this is one of these pillars. He began working with the base with elephant feet and began constructing with 3 phases the pillar. Each phase had the 2 squares turning as a base. These squares were rounded with hyperbolas, and in each dam, one dam for us is a dam of stone. Each dam has the perimeter, all the skin on perimeter, with a succession of little turns that are expressed in the parametric table. With little turns, the intersection of the surfaces gives us the result climbing dam by dam. This is the first phase with 8 meters high, the second phase with 4 meters high, with the drums from 1 to 4, with a finished with 32 edge, and the last phase, the first one, with 2 drums and 64 edges. If you see this form, not by microscope, but with an augment, you can see that it's not a circle, a perfect circle, but the reality is that the transition in each pillar is from 2 square turned 45 degrees to the circle in the knot. In the knot, because we have the finish of the trunk and the beginning of the branches. Like in nature, the trees are like this. In geometry, the trees are like this. The knot in the point of arrival of the trunk and initiation of the branches, the point is 2 pentagons with 2 squares that develop the geometry through an ellipsoid. And these are the 3 knots of the pillars of the main nave with these ellipsoids in the envelope. These are the ellipsoids, and this is the intersection of one ellipsoid of revolution with the cylinders of the trunk and the branches. You can see also a difference between these 3 pillars is the color of the. It's not only a question of color, it's a question of material. For Gaudí, when he worked with antifunicular calculum, he conceived that the same section would be able to support more load if the material had more mechanical capacities. Then, for the ordinary pillars, he used the pedra de Montjuïc. La pedra de Montjuïc, the Montjuïc stone, is a sandy stone. He used also, for the next resistance step, he used the granite. Then he used the basalt. And finally, he used the porphyrium. This is the strongest stone he knew, and the porphyrium came from Iran. But if you have finished with the branches also follow the phases and the conversion from pentagons turning or squares turning and finishing in circles. That has to support the bolts. The bolts of main nave are mainly conceived with little models, repeat many times. And we find the 125 scale plaster model, and he worked in the vaults with hyperboloids, and the intersections between pillars and holes to let enter the light were parametric also in relation of the multiples of the distance between the pillars that contain one hyperbolic model that had holes in these positions and in this other position. This is the image from the central nave upside. This is the view by day. Maybe this afternoon you see something similar. And this is the view by night. For him, this had to be the copper, the crown of the forest. after the vaults, we find the other difficult geometrical problem. This is the towers. We have 12 towers in Nativity, Passion, and excuse me, maybe here I can, no, yes. This is Nativity facade, this is Passion facade, this is Glory facade. Each of these three facades has 4 towers, but is in the center, in the crossing of the Basilica, that we have the biggest tower, is the Jesus Christ tower, and 4 towers around him that are the 4 evangelists. And after Jesus, just over the apse, we have the Mary towers, the Mother of God. Then how is possible to trace and to obtain a law to construct these towers? His proposal was on a big stone with the form of sacristy. And he described with the traces the hyperbolic paraboloids that were asymmetric one of them and symmetric the other one. This is the result of convert these hyperbolic surfaces. The red ones are symmetric, the green ones are asymmetric. Then we can obtain the surface and the nerves and the arcs of the sacristy. And the same for the towers. Is exactly the same geometry, but higher. Then this is the sacristy, the plaster model of the sacristy, and this is the conversion in computer. And that was the big legacy of Gaudí, that when we arrived in 1986, then 60 years after the death of Gaudí, we find all that. We could formulate all the proportions and dimensions we had to respect, and we began to work with these laws to prepare the models of the new building that were lost or were burned because at the Civil War. During the Civil War in Barcelona at 36, the workshop of Gaudí was burned and most of the plans disappeared, but the plaster models, more or less broken, was possible to reconstruct it, and were the best source of information. We find a lot of graphical information, but the main information is the plaster models. Then we began to construct also, but not plaster models, but computer models. And we began at 80s. Sorry. This new era was a new way of construction, because we began the new step in Sagrada Família. Till 80s and 90s, we construct with more or less conventional systems, but from 90s, we began to project with another system. This is the pre-industrialized construction. This means we are sure that the building now is more or less at 85, near 90 meters over the street, but it have to arrive at 170. the question is how to make all this big building over another big building and maintain the building under visits. Many of you, I know, this afternoon will go there. Then you know that 80 meters over your head, there are hundreds and thousands of tons of structure that are at this moment mounting and constructing. Then this was an obsession from the first day, but now it has a lot of sense, more sense to work with the maximum security. Then we concede the new era of works beginning at the quarries. Go to the quarry, try the blocks from Basque Country to Galicia, United Kingdom or Iran, and work there the cut and dimensions and put on the necessary dimensions the blocks there at origin. The blocks are taken to the preparation workshop, is near Barcelona, near Manresa, at Galera, and the blocks are sculpted, polished, and machined there, and pre-assembled, and stored, and mechanized, and post-tested, and assembled in panels. Then here you can see the works of press-stress, here the mountings of the panels, and finally the panels we have to mount on work. When that arrives at the work at Sagrada Família, we have to elevate it, place, and mount with this kind of precision. This is one panel that may have a load around between 10 and 20 tons. Work with and hanged from 100 meters and with the precision to take it from the street and put it on place with not very much tolerance. We have tolerance, of course. Then, one time we have the panels on site, we put the pieces to fix it. All the structure is in stainless steel. All the armors are also in stainless steel, and the guides to enter the panels are the own structure, the metallic structure we have inside. Then is a nerve that follows the geometry of the paraboloids and the paraboloids, and these are the guides to enter the panels with the same geometry. When we have fixed mechanically and with all the edges covered, we concrete the space that we have between the metallic structure, steel structure, and the stone substructure. Finally, we make the sealant between the pieces, the different panels. Here is very easy to see. This is one of the panels. This inside is the stainless steel structure. And this is one level finished with the arrastones. These are little edges with another kind of stone. And this is the models, the panels that we mount inside. Here is a upside view. And this is the rhythm that we can exprime to this part of the works. Is the most important, the most risky solution, because we have, as I said, we have not a lot of tolerance. Then when you don't have a line here, this is a curve. This is an hyperboloid that don't climbs through here, but climbs to here. Then this is one direction where you have to put inside these little panels and make that all the pieces work together. This is one of the solutions, mechanical solutions we have to make the union between one step and the other. You can see here the steel structure with the lower panel. You can enter the other panel when you have the other level. Then all that is the result of projects during 8 or 10 years, and with many people in the world implicated. This is a resume of that I explained. This is the works on the blocks. This is the presentation of the panels, the pretension, the press-test of the beams, and the assemblation between lintels and pillars, because they are all press-tested, and the assemblation of these bars press-tested to form a panel press-test. These are the works, the precision works, and when you have that, you put, this is one of the stainless steel pillars that's fixed with the under pillar, and here you have the entrance of the panel that slowly enters through the point of connection. This is another stone that's placed in the corner to finish the envelope of the pillar. This is the union between panels, and this is the preparation that's at Galera. No, it's not in Sagrada Família, but it's exactly the system that we are using now in Sagrada Família. And this is the arrival of the last panel that we have in this model. You can see this is the point that have to exactly found the one model to the other, and that's one of the 200 models that we have to make only in the Evangelist Towers. Let's change a bit of question. Weights and materials. We have here an example of the no wedge. See, Viollet Leduc made at I can see the date. Wait. No. At 19th century. I don't see the year. He made the pinnacle over the crossing in the Notre Dame de Paris. All the pinnacle had a weight of 750 tons. And the towers of Sagrada Família and the solicitation for the building are a little bit bigger. The main the main pillars, these are the Jesus Christ pillar. Every column has to support 6,150 tons. This means that if we add the 4 towers, we have 24,000 tons. This is a high and heavy building. The other columns are not aggressive. They also have a weight, a very important weight. And why we have these loads? Why we have these weights? Because it's a very high building. 170 meters is a very high building, and Gaudí doesn't calculate the effects, because he couldn't, the effects of the horizontal loads. Wind or seismic actions were not possible to consider with the antifunicular models. Then one of the first works we had to do when we arrived at 1986 was the validation of the foundations, existing foundations, and the project of the new foundations. Then we had to calculate one building of 12,000 square meters, very, very quick to conceive the foundation and repair the existing foundation if it wasn't enough. It's the case of the crypt foundation. We had to reinforce strongly to construct from here to the top. In this case, excuse me, this is a small drawing, but you can see that the foundation of all these pillars are with piles of 20 meters deep that doesn't cross the phreatic level and can support the actions we considered in 86. Then this was a reinforcement, a local reinforcement with micropiles and arms. And from here to the upside, we knew that the structure has to be the rest between the skin, because the skin was the project of Gaudí. Then we had to respect absolutely the geometry of the project of Gaudí, and we had one stone skin around the pillars, around the vaults, around the arcs that we had to conserve. Then, as you've seen in the animations and last image, the structure really have very loose space. Then this is all the iron we have to put between the stone skins. You can see here, this is a skin of stone, a wall, inside one of the staircases of this is one tower of Evangelist, yeah? And this is the arrests, the arrestants you can see outside. Then we can put concrete here. You have to think that the Evangelist towers will have 135 meters. And now we are at 80 and between 80 and 90 meters from the street. These are the works we have. This is from 3 years ago. That's absolutely covered now, but we can follow. This is to explain what kind of works we did during all these years. This is the Mary's Tower. Then this is the apse, over the apse. This is the base of Jesus Tower. And these are the evangelist towers that will connect at this level, are absolutely connect with the Jesus Tower, but when at 100 meters, they are absolutely separate. And this is one of the 4 sacristies that will have the Sagrada Família. Now this one is finished, it's occupied, and a part is visitable. It's possible to visit it. And at this moment, you have only structure. When we worked here in the sacristy or in the towers, we had that we construct the structure with a provisional pillars to add, after the construction of the structure, add the facade and made that the facade has also a structural paper. Then this is one model. You can see it here. Here we have, like in the project, the arrestones. This will be another arrestone, and that provides from this geometry. And the sacristy will be finished as the project. Okay, this was a chronography of our works, but our desk, our studio, is especially dedicated to the structural solutions. And when we began at 86, we had a big problem, a little problem, that was we had not so strength in in programs of computer structural design that could process a so big building. Carles Buixader and Joan Margarit are our senior partners in the desk, were catedràtics in structures in the University of la UPC, la Politècnica de Barcelona, de Catalunya, and they conceived one solution in the Vitoria market, that in the year 1975, they convert the laws of laminar calculation, they convert it in an assimilation, a process of assimilation from plate to bar. That was that gave them the possibility to calculate an 84 meters dam only with a 7.5 degrees of the structure to calculate. This was possible to calculate because he had only 1,000 bars. This was a limit to calculate at 75. At 85, the limit was 3,000 bars, but for the Sagrada Família, that they had to calculate absolutely the building to know what kind of foundation. That was the first works they had to begin. To define the foundation, they had to calculate all the building. Then they made the hypothesis, and one of the simplifications they did was the assimilation for the vaults of the nave to guarantee that the rigidity of the roof was in calculus, because they only need the reactions, okay? But they need to simulate what kind of rigidity had these levels of roofs from the nave. This is at 30 meters high, this is at 45, this is at 60. At 1995, we adopt the finite elements method that had not the limitation to work only with bars. We could work with finite elements, and the finite elements had the possibility to work with plates or with volumes. And they could simulate the birth and the death of some of these elements. That was very important for us because we work in a building with the old building construct in the Gaudí era was with a stone. The stone is not able mechanically to support tractions. Then the simulation of the breaking of the stones was basic for us. This was the main problem we had, because the analysis with the elements could be analysis, an elastic analysis. That means the deformations are proportional to the actions, or plastic mechanical properties that could let residual deformations. Okay, then we worked with finite elements, and now we made another step. The last step we made is something that was very, very basic for the future of the building. That was when we work more than 100 professionals in the same project. We need a platform of networking that could incorporate structural, geometrical facilities, etc. We adopt the BIM, Building Information Modeling, which the letter I is the most important because it's information. It's there where we place what category or what capacity we need of steel or the stones or the concrete. This means that our environment in BIM that we work now in Sagrada Família bases BIM design software. This is all plan Rhinoceros and the support of Grasshopper. BIM structural analysis with ANSYS and TreeCalc, and BIM viewers in Tecla. We have also a BIM cost control to quantify each decision, which is the cost that it means. In the first phase, when we receive the design from the technical office of Sagrada Família that defines the geometry and the materials, we need to obtain some information. This information could be a plate, could be an axis, could be a point, or could be a liaison. All that is only input information. We take it from the model and we process it with a platform of programmation, visual programmation, that converts this information as an input geometry. This was this small square here. This other is the environment of Grasshopper for programmation. Here we have this input information. This is the database with the main information we need in relation at materials available and distance, minimum distance we need to have the tolerance we need. And these are the outputs. These are, no estic llegint res. No, script, sorry. This is the script. Each each solution we need to solve has its own script. One script for particular cases, no, but arrestons here, pillars, vaults, all the solutions we have to solve, all the tolerance we have to guarantee, we have the programmation here. Then we have the output. This is that. These are measurements, and the output are the dimensions that permit automatically obtain that. That's the geometry of the structure we can put with the geometry they gave us. This is the result, and this is what permits us continue this new era of construction in Sagrada Família. Finally, some image of the finished space. You have seen something that normally nobody sees, is the workshop is outside of that. Today, you'll have the luck to go there. And I ask you to remember that Gaudí, when he tried to make a temple where the sensation must be to be into the forest with the light crossing the leaves, this is the vision you'll have today. If you see this lateral facade by the front, from frontal, you can see the classical neo-Gothic facade. But you have to go to see by side. This is exactly the same facade, but not looked frontal, but by side. This light is in the facade. The facade projects the light to the core and the pillars. You can see the colors of the pillars with the difference of the materials. And you can see the light that comes from the vaults. This is the same object of Gaudí. The light enters everywhere. And this is the view, the main nave looking to the apse. And we arrive to the crossing vault, to the crossing of the naves, excuse me. And if you see upside, you'll see that. Then I like to think that with what I have told you, you will know how to look more attentively this great building. And I hope that this last image of the interior don't ruin the surprise that I'm sure you will have this afternoon on this site. Thank you.
Thank you very much, Carlos, for such nice presentation, and time for questions. Is there any question?
Hi, thank you for this talk. I've seen a lot of letters like M and W, and I would like to know if that's linked to some of symbolism. You said Gaudí was a bit religious.
M and W.
M and W, it seems the forms of structures.
No, this is, yes, it's not symbolism. This is the trace of the grid, a structural grid in the facade. If you, I don't know, there's, can I turn back a bit? Oh. No, I think that's enough. Okay. Okay. If you look here, this is the paraboloids and hyperboloids, and inside this rolled surface, you have a trace of normally based on triangles, because the triangles with 3 points could define a plane, and the ruled surface are based on lines, and you have always planes inside. This is the way to enter the light in the ruled surface.
What went on with the building between 1926 and the 1980s?
Well, there was some old collaborators from Gaudí, and at 1960 began Jordi Bonet. Jordi Bonet was the chief architect that made more impulse to the construction. From 26 with the civil war till 39, and the post-war with works almost closed, the evolution of works were very, very slow. From 60s with Jordi Bonet, that was the chief architect, the Sagrada Família changed a lot with more donations, and these donations permit to construct a good ring, and when they could finish the Passion facade, and they closed around the apse the Nativity and the Passion facade. But at this moment that they have seen that the continuity of the works needed a bigger team. Then from 60s to 80s, the technical team increased and permit to project the works that now we are following. Then from 26 to 86 that we arrive, there are some old collaborators of Gaudí and new patrons, technical patrons.
When it will be finished, the building? I didn't buy any tickets.
Always
so
fast, always fast. The intention now is to finish the temple at 2026 is 100 years after the death of Gaudí. This is an objective, but at the rhythm that we are working now, I think is very realistic. But I can't promise it because it doesn't depend only for us, of us.
There was another one question. Another question in the back.
Who's funding the project, and do you have a cost estimate for completion?
Well, I think ICALEPCS today will make a donation to Sagrada Família. Yes, the only at this moment the only economic apportations are from the tickets to enter. 4.5 million visitors at 2016 means, well, you can make the multiplication. It's easy. It's enough to construct at the rim that we are now going.
Is there any question else? The last one. Let's do the last one.
Have you discovered any mistakes where the math or geometry of Gaudí just would not work?
No. Well, yes, but they are solved. No, the mistakes. The only question is when you found a law, and you don't have this law written on a paper. Maybe there are exceptions that the law doesn't contemplate. Then there are some dimensions that we don't found at the project of Gaudí. On the 12th series of pillars or vaults, we don't found, for example, the number 4. There is not any object with 4 model. It exists, but I don't know if that's a mistake or it is a mystery only.
Let's close the session. Let's thank Carlos again for the speech.
Thank you.